Today we're talking about graphing cubic functions. So a cubic function has a degree of 3, and they kind of mention the standard form over here and the basic parent function y equals x cubed, right? So we're going to deal with the parent function to help us learn to graph these. And basically what you're going to do is you're going to take the number that's in the x column and you're going to take the cube of that. So for example, the very first one we do -2 and we cube it, and you should get that that is -8. Okay, and so what we're going to do is we're going to say, hey, yeah, that equals to -8, and we're going to kind of follow that pattern all the way down. So -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. And then let's go ahead and graph this original parent function. So here we go, -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. This looks a little funky, but this is roughly what your graph will look like. Okay, now these are not straight lines, they are curves. Okay, so make sure that you're not trying to draw straight lines to connect those. All right, some quick details about this before we go further along with the graphing. Okay, so a cubic function's domain is going to be from -infinity to +infinity. And you could also write that as being all real numbers, okay, with the little double R. Range, same thing, similar to the domain, -infinity to +infinity, or all real numbers. The end behavior, guys, you can see that the arrow goes down on the left and up on the right. So if we were writing it out formally as x goes to -infinity, f of x goes to -infinity, and as x goes to +infinity, remember that means going to the right, f of x goes to also +infinity going upwards. All right, so showing your left arrow is going down and your right arrow is going up. Okay, and then they mentioned zeros. Okay, the 0 is actually just that one point in the middle. A cubic function only has one 0, and originally it is at 0.0, comma 0, the origin. Let's write that a little nicer. There we go. Okay. They mention where are the values of the function positive. It's not super duper relevant to us, but we'll just mention it. It's when x is greater than 0. Okay. And then when are they negative? It's when x is less than 0. So if you put in a negative, you get back a negative. You put in a positive, you get back a positive. Okay. We'll leave off increasing, decreasing. We don't really need to talk about that. All right. Let's take a look at some of these graphs now. So pause the video for a second and make sure that you have all of these details down. I'll scroll up a little bit in case you missed any of the points. Okay, so you can pause the video here to make sure that you've got that down. Okay, so on the second page, you'll see, hey, there's some examples of how we would graph this. Now, it's the exact same way that we graphed the radical or the square root functions. As long as you understand the transformations, you can't really go wrong making these graphs. Okay, so if we look at number 1, you'll see, hey, like x plus 4 cubed. So that plus 4, remember, is always backwards inside the parentheses. So that is left 4 spaces. And then the -6 that we've got here at the end is actually going to be down 6. Okay, so what we know is our graph should move left 4 and down 6. My original points are the ones that we mentioned above, right? So we had the x values that we were using initially were -2, -1, 0, 1, and 2. And my y values, which were x cubed, were -8, -1, 0, and 8. So now let's make the adjustments we need for this, and then we'll be able to see our new graph. So of course, we're going to move our x's to the left 4 spaces. So we've got x minus 4. We're going to go down 6 spaces, so y minus 6. Okay, so here we go. Subtract 4 from each of these numbers. -2 minus 4 is -6. -1 minus 4 is -5. -4 for 0. -3 and -2. And then take 6 away from each of these. So -8 minus 6, -14. -1 minus 6 is -7. 0 minus 6, -6. Then -5. And we've got 2 as our final number. Okay, so now we just graph these points, and you should see, hey, it's going to look pretty similar to what we have already seen, except it's been moved kind of down and to the left. So -6, -14 isn't going to fit, so we'll just skip to the next one. -5, -7, -4, -6, -3, -5, and -2, 2. So this piece you can see is going up, this side's going down, and I know the -6 point sticks off, so I'll just kind of do that. So you can see, hey, it does have that same curve kind of shape, but it's definitely been moved to the left and down. So guys, again, just pointing out a couple details here, right? The left 4 meant that we had x minus 4, and the down 6 meant that we had y minus 6 to make it go down, okay? Always try to follow what you know the behavior is supposed to be. Don't try to think about the math and the numbers too much there, okay? If it says down 6, you know that you got to subtract 6. If you know that it says left 4, you've got to subtract 4, even though in the problem it said plus 4. Okay, so once again, guys, pause the video if you need. Make sure that you have this graph down. Okay, guys, so on the next page, let's look at number 5 and just see kind of how this one works out. So again, we'll just make a note. My original points are -2, -1, 0, 1, and 2. And those were my x values. My y values are -8, -1, 0, 1, and 8. Now, my new values, let's think about how our functions moved. Let's just start with this. This one is going left 7 units, okay? And then that -4 at the front is actually two things in one. Remember, it's going to make your graph reflect or flip, and it's going to make it stretch. Okay, so it's actually 2 in 1, but we can cover that all in one single math step, okay, which makes our life a lot easier. So here we go. To go left 7, I'm going to do x minus 7, and that -4 in the front is just -4 times my y values. Okay, so let's see where the math takes us. -2 minus 7 is -9, -1 minus 7, -8, -7, -6, and -5. Times -4, we've got 32, +4, 0, -4, and +32. Now, of course, the 32s are going to stick off, but we can at least get that middle part pretty well set in here. So we got -8, 4, -7, 0, -6, -4, and -5, 32 again, sticking off. So you can kind of imagine, like, hey, this is kind of going way down, and this one's going way up, okay? So you can see still kind of the same shape. It's just been stretched out, so the curve isn't super visible, okay? Once again, guys, pause, make sure that you have this graph down, and then we can look at that last bit. Okay, now looking at the bottom of your sheet, guys, we can talk domain range and stuff. You've kind of seen that already, but let's look at number 10. We'll do one or two of these and then kind of move on. Okay, so number 10, we're writing an equation based on what information they've given us. So the first one says we've horizontally translated left 4, shrunk vertically by a half, then vertically translated down 2 units. Okay, so the first thing is I know that my function originally starts out as an x cubed. So I know I've got x and then a cube. Okay, so to go left 4 units, we're going to do a +4. Remember, it's backwards, okay? So that one is +4 inside, okay? That's kind of the key thing, and I know that looks super messy, so we'll rewrite that, okay? Now, shrunk vertically by a half, that just means you have to put a 1/2 in the front, okay? That's how you get it to shrink vertically by 1/2. And then down 2 units is going to be -2 at the end. Okay, so there you go. There's your equation. And if we wanted to be super formal, f of x is going to equal 1/2 x plus 4 cubed minus 2. Okay, now why don't you guys try the next one, and then I will show you the solution that I came up with. So go ahead and pause this, try that one, and then let's see how we did together. Okay, so I came up with f of x equals 3x cubed plus 13. And now we've got this equation. Now, one thing to note, guys, that 1/3 was a horizontal change, and that's always backwards. That's why it's times 3. So just watch out for 1/3 horizontal is actually times 3. All right, so that's just kind of one of those weirdo ones, but something to keep an eye out for so that we can see like, hey, that's a horizontal change and one that we haven't talked a lot about. Okay, let's do that last one together real quick just so that we see it. Right, horizontally translated 7 units to the right. You already know that is x minus 7, right, backwards, cubed, and then reflected over the x-axis, that's a negative in the front. Okay, so we got f of x equals negative x minus 7 cubed. All right, so guys, that's graphing cubics in a nutshell. Make sure that you complete the assignment that's given to you guys about this. All right. Best of luck with this.